Yes. So what we will do, we will utilize the time effectively from today till 10th of February, so that we will be ready with all the resources and the tools, so that we can do our exercise of creating our autonomous mobile robot on 11 to 13th. The 3 days we will be effectively utilizing for the same. So I welcome everyone here in this group, and we'll start with a quick round of introduction with the people who have joined today. And it is a very small group. So what we want, we should be more and more interactive and then discussing things together, because this is just a informal discussions that we will be having during these days. There is no as such lecture to be planned as right now. It's a kind of an interactive session. And same what we will be expecting, that during the bootcamp days also we will be interacting closely, so that we will be helping you out whatever activities you will be doing. And that's a way that we will be able to create a real good platform. So what I will do, I will first introduce myself. You may be aware of that. My name is Sunil Jha. I am a professor in mechanical engineering at IIT Delhi. I have a lot of passion to create robots myself. So I did a lot of creations on my own. And that's how I am connected with the robotics club at IIT Delhi. And I am a part of this organizing committee for Robocon 2022. So I'll start with Venkat.
Hello, I'm Dr. Venkat. I did my PhD from electrical engineering. I'm the manager in education and training at iHub Foundation for Robotics. And we are together with DD Robocon activity at IIT Delhi since 2 years.
Thanks, Venkat. So I will request those who are introducing themselves, please make your video also on, so that we will be able to see each other, because this is a first session, and introduction also required that we should meet as we will be meeting physically otherwise. So we'll go with the Aditya Wagh.
Hello, sir.
Hi, Aditya.
Am I audible?
Nice background. You are on sea beach.
No, no, I am in my library. Sorry.
Yeah, sure. Please go ahead.
Yeah, I am Aditya Wagh from Walchand College of Engineering, Sangli, the vice captain of Vulcan Robotics.
Oh, great. Good to see you.
Good to see it.
Ashutosh. Ashutosh, are you there?
Yeah, hi, Professor Jha. This is Ashutosh from IHFC.
Yeah. Good to have you in this meeting.
Thank you.
Thank you. Dhananjay Arne.
Yes, sir. So my name is Dhananjay Arne. So I'm for VIT Bhopal, and this is my first time participating in Robocon.
Oh, good.
Yes, sir.
Welcome, Dhananjay.
Thank you, sir.
And next we have Harsh.
Hello, I'm Harsh Sharma. I'm part of DD Robocon activity, and I'm part of organizing committee also. So,
Thanks, Harsh. Thanks. Himanshu Chaudhary.
Hello.
Hi,
sir. I'm Himanshu Chaudhary from SNW College of Engineering. This is my participant in the Robocon Bootcamp activity.
You can tell at least your branch and the area.
I am from Artificial Intelligence and Data Science.
Okay, great. Good. Thanks, Himanshu. Next, Kalhar is there. Kalhar Pandya.
Hello.
Yeah,
myself Kalhar Pandya. I'm in IIT from past 4 months. I'm helping with the Robocon organizing committee. And apart from that, I'm working on the autonomous robot project. And I'm also part of a Falcon Robocon team. I was part of the Falcon Robocon team.
Thanks, Kalhar. We have Kivalya Pandya.
Good afternoon, sir. I'm Kevalya Pandya and I'm from Birla Vishwakarma Mahavidyalaya. My major is mechanical engineering, and I'm in third year. I did my internship with you in FSM during summer.
Yeah, correct. Thanks. Thanks. Who is next? Mohit Bendale.
Good evening, sir. My name is Mohit Bendai. I am from PVPIT Baudan, and I am in last year mechanical engineering.
Okay, thanks. Welcome, Mohit, for this meeting. I am allowing whoever is coming. Venkat, you can just keep a check on that.
Yes, sir. Yes.
Pankaj. Pankaj, are you there?
Hello.
Yeah, Pankaj.
Hello. Very good evening, sir. Myself, Pankaj, and I did my mechanical engineering. And now I am working in IIT Delhi as a senior technical laboratory assistant. Thank you.
Good. Thank you, Pankaj. Thank you. Paras.
Hello.
Hi, Paras.
Yes, sir. My name is Paras, and I'm working in IIT Delhi as a senior laboratory assistant, and I'm taking care of your mechanical designing part in the Robocon training session.
Thank you, Paras. Thanks.
Thank you, sir.
With us. Pradeep Tripathi. Yes,
Good
Pradeep.
afternoon. Good
Yeah.
afternoon. I am Pradeep Tripathi, second year from Mechanical Department, IIT Roopur.
Oh,
And
thanks.
I want to learn much about from others, and I am highly enthusiastic about robotics and software engineering.
Thanks, Pradeep. Welcome, welcome. I am sure that you will learn a lot while we are doing these sessions.
Thank you, sir.
Thank you. Sakshi.
Hello and good evening, sir.
Good
I'm
evening.
Sakshi Gadigar from St. Vincent Pallotti College of Engineering and Technology. I'm in second year from IT branch.
Thanks. Welcome to this meeting.
So we have two logins, Ms. Shakshi. Can you cross-check that one?
Yes, sir. Actually, it was a glitch in between, so I have connected from phone also.
Okay, then I'm removing one.
Okay. Sri Ranganathan. Sri Ranganathan. Are you there, Sri Ranganathan? You are on mute if you are speaking. We can't hear you. So we'll come back to you. If you are not there, we will just then again remove you. Siddhi.
Siddhi is not part of the program. I don't know.
Okay. Anybody else joined with the name Siddhi? Please speak it up so we can just verify.
We can go with the next name, Yash B.
Yeah. Yash Bihani. Yeah, Yash Bihani.
Hello, sir. My name is Yash Bihani, and I am a student of Sanjeevani College of Engineering, Kopargaon. I am also a second year student of Mechatronics branch.
Okay. Thanks. Yes. Thanks.
Thank you, sir.
Thank you. Anyone left out? I have already read all the names. Maybe
We have
someone.
Gauri, and Divya to
Okay.
introduce themselves.
So Gauri, you can start.
Hello, sir. Good evening. I'm Gauri Patil from Cummins College of Engineering. I'm third year ENTC student and I'm part of our Robocon team.
Okay, thanks. Thanks, Gauri. And who is next? Divya? Divya Kirtana. Are you there? Okay, anybody else left out before we start the session? Okay, fine. So I think with this short introduction, we will certainly get introduced to each other more when we do activities together. So what I will do, today's session is important from the point of view that we are looking forward, as I was mentioning, that we will be getting ourselves ready for this bootcamp activity. And we will be utilizing these 15 days time to learn the resources as well as make the resources available to you, so that the last day it will not be a struggle to get something done. So idea behind this activity is that we will be intent to create a physical robot platform or robotics platform for Robocon, which may be used for the Robocon activity as well. So in that case, I just want to understand from the people here, how many of you are willing to create the platform physically, or you are just willing to listen and understand? So can you raise your hands to indicate that you are willing to create the hardware also, as we will be doing in this event? Otherwise, you will not be enjoying. Actually, there are other tutorials on the web which you will find that you will be able to see how to do the things. But unless you do yourself, you may not be enjoying how to create a robot. Good, I see many hands are coming up. That's really nice. At least we have 3, 6, 7 people now who are willing to create a robot with us. Yeah, good. Others also, I will encourage that whatever best you can do, please participate in this activity. It is not very costly affair, because you are already intent to work for Robocon, and then even if you are not having a team right now, you can at least get reach out to your friends basically to create the team, so that you can actively participate for the Robocon and get the strong team ready from your institute. So idea behind this bootcamp activity was that because I was also observing this Robocon from last many years, and we have witnessed many live events also. And 2019 is certainly the live event happened at IIT Delhi. We always see that the kind of robots we are expecting basically, because we are all engineers, we are looking forward for more engineered systems and the machines. And whether it's in a design part, whether it's in a manufacturing, it's in a electronic systems, the programming part, I see many times in the game field or before the game field, the last moment struggles going on in your camp, basically while you are coming for participation in Robocon. Why these kind of things are happening actually? So if we go in a much structured way, the way in the industrial products are being designed, you will not come at the last moment surprises actually. So what we will be doing in these sessions, that we will be giving you tips and tools basically how you can create a much more robust design, and how you can be creating a robot which will be able to perform the task much better, so that you can be winner in the Robocon also. Be certainly participating in various games. But idea is that we will be intent to create a good industrial rugged platform which can be used multiple times, because the way you see the Robocon activity going on, it's not just a one-year activity. We see that Robocon themes are changing, Robocon problem statements will be changing, but there are certain components which are fixed actually, which has to be there actually. There's not much change is going to happen. As you might have seen that most of the Robocon games, there are mobile robots required actually, and there are platforms which are supposed to move on the game field, which is roughly around 10 meter by 10 meter or 10 meter by 12 meter. There are certain robots which have to move within the field and perform certain tasks. Only, I think I have seen only one instance where the legged robot was introduced, that is in 2019 only. But earlier, most of the games, you need to have a good mobile platform with the wheels which can move around in multiple direction at much higher speed, because you have to compete with your opponent. and then you will be performing those tasks. So if you can create a very good platform and which is going to last for participation in multiple years, that will be good actually. So the investment that you are going to do is not just for one event or one activity. It is going to last with you for and you can for many years and for participation, and you can keep on adding the different mechanisms and the additional hardware that is required to address the game theme. So that is the basis. So this is just a start of the investment that you are doing right now. And those who have not participated earlier, at least you can create some mechanical. May not be if you are looking forward for a much bigger platform, but at least you will be create a decent platform which can be used for learning. So that is the intent for this. And today's meeting, I will be just taking you through briefing on the materials that is need to be arranged basically for participation. And certainly we will be sharing more details electronically also. So what I will be doing, I will be first sharing with you the platform that I will be using to create an account for you, and then we will be sharing all the learning material onto that. So let me just share that screen with you. So this is a website that is an e-learning website by FSM. So FSM Skills is the website. The domain is fsmskills.in. We will create an account for all of you, those who have registered for this event. And there's a course over here. If you can see here, it's a Robocon Bootcamp actually. So what we will be doing, we will be populating the content into this course. So right now, if I click it here, I will go to the course page. And right now, I have not added anyone as a participant, but I will soon be adding after this meeting the participants in this course, so that you will be able to see all the material that we would like to share with you. So for example, we will be starting with the robot BOM discussion today. So after this meeting, we will be adding all the bill of material details, link, everything will be available over here. Similarly, as we go along, we will be adding more and more content over here. And during this activity also, we may be asking you to do some design activities, and maybe asking you to upload some of the design files to just validate and have a look at that. So all those two-way information exchange can happen on this platform. So we will be using this platform as a learning platform during these days of the boot camp. Someone has raised the hand. Can I see it again?
I think it is Pradeep.
Yeah, Pradeep, any question? Yes.
Sir, it just looks like a Moodle system of our IIT domain.
Yeah, it's a Moodle only. Only thing is that we are hosting our different training courses on that. So it's
okay. So do we have to
Moodle
register? Do we have to register on FSM Skills also? Or
no, what we will do, we will create your account based on your email ID and phone number that you have submitted. So and we'll share the password with you.
Okay, sir. Thank you.
Okay, fine. Any other question? So please be more interactive, interrupt me wherever you need help, or just make the things more and more clear while we are going along.
Sir, I already have FSM account. So if you will be making one from your side, will that override my existing
that is okay. If you are having an FSM account, then we will just enroll you in this course. That will be okay.
All right, sir, that would be great.
So let me share my slides now, what we are looking forward for today. So as I was explaining in one of the session earlier, there are different type of robots that we all understand. So there are grippers, basically articulated robot, multiple degrees of freedom are there. So it's a kind of an arm that you will be creating. It's in a mobile platform like this, which maybe the base is mostly seen like this in the vacuum cleaning robots. And this is one of the turtle bot being used to learn the ROS. Then this is the one which I was talking about, has been given in 2019 to create a legged robot. That Robocon challenge is around this robot. So this is one of the robot design you can see, which is having a similarity with the legged robots. And there are a lot of popularity of the legged robot also around. So certainly whenever it comes in Robocon, we can again look forward that to create a good design for that. Otherwise, those who have an interest, they can anyway find a lot of resources. When we were talking about the Robocon robot, that is what I was just explaining, that in all the years of participation for the Robocon, you find that there is a base, and then there are a lot of mechanisms added on top of that. So you will be coming out with the designs of different mechanisms. The concept of those mechanisms can be thought through by brainstorming between the team members, that how they will be going to attack the problem for that game. So that's a way that we will be starting with the base design, and slowly we will be discussing some of the mechanism which will be useful for the participation in the Robocon. So different wheel-based designs are there. So certainly we just captured some of the wheel-based designs here. So that's 4 wheels placed around the platform. So that, see, most important part is the maneuverability in the multiple directions. How quickly you will be able to move and take turn and then reach out to a particular place in the game field. That is the basic idea. This is another design of the wheelbase. You can have a differential drives over here with one omni wheel caster, or you can use another type of casters, rolling wheel also. This is another design with the 2 casters basically on the front and back, and the 2 differential drives. So there are various wheel bases that are being used. We'll be starting with one base design, and certainly we look forward for any other possible designs if you can work on. So you may be manufacturing one design, but based on your interest, you can even design and then analyze the other type of robotic platforms as well. So as I was explaining, that we need to understand these 3 tasks while we will be creating the robot. First of all, the material that we are looking forward, and we should have that material to create the robot. And then certainly how we will be assembling the different components of this material so that we can create this basic platform. And then assembling the electronic circuit on top of that and make it run actually. That is what all we will be doing in this activity. So this is the basic wheelbase that we will be using right now for the bootcamp activity. So we had this 4-wheel mechanism wheel design, and roughly the size is around 500 by 500 millimeter. This is 0.5 meter by 0.5 meter, because that's a normal size of the robot for the Robocon. So we'll see that what all materials are required for making this wheel platform. And that is what we will be taking you through, this detailed bill of material for the bootcamp and list of all the items required. And this list will be made available on the website also. That is what the FSM skills platform that we were mentioning. But let's have a quick understanding and look at this bill of material. So I appreciate the efforts done by the team at IIT Delhi to compile this material. We already have this one set of material available with us, so that we will be creating the robot as we go along with you. So my idea is that once we have this list of bill of material, you can have a quick look at that list. We will also be providing all the links from where we have bought this material. Roughly within 6 to 7 days, you will be able to get all the material at your place once you place order online. So nothing to worry. Even if you are working at your home, it doesn't require much effort. You can easily get this material available to you. And there are very minor tools are also required to make this robot platform, and which I will also share towards the end of this. So it doesn't mean that if you are not at the workshop or in the institute, you can't do this, but this activity can be easily done if you are still at the home. With the minor tools, you need to put little bit additional effort, but you can easily create this platform. So the first component that you require is certainly the motor, which is a high torque motor. This motor we have selected is with 370 RPM and 147 Newton centimeter torque. And one motor cost 2,299. So this is the cost available on the website. And if you can, I will recommend that you will go with the same component which we will be recommending to you, so that it will be easy to use the same design and follow it to create the same robot that we are looking at. We require 4 right now in this design, but when we go for a differential drive kind of a design, we may require 2 motors only and the 2 caster wheels. In this design, we will be using 4 motors here. This is a bracket for mounting the motors. So as we go along, we will be doing this assembly ourselves. So we'll get the motor separately and we'll put that in the bracket, and this bracket has to be mounted onto the robot wheel base. Okay, fine, Venkat. So you can take care of the people. I'm not allowing them. So depending on your list, you can just validate and then permit. Fine. So we have also mentioned the cost of these materials, and so that you will get a fair idea about how much the whole bill of material cost. This is the encoder that we will be using, and encoder is a very important part of the robot for the odometry. Because you have to measure how much rotation the wheel move, and accordingly you will be finding out the displacement of the robot, and then in which direction you will be turning. So all sort of odometry calculation can be done from this input coming from this wheel encoder. So this is the encoder we require on all the 4 motors, and this can be easily attached. This has been designed to be fixed with the motor that we have mentioned, so that most of the material that we have selected, they are compatible with each other. That's the important part. So if you go with a different part number, different material, then you may find difficulty in fixing them together. So that is what our recommendation is, that we have already spent time in selecting this material. So if you go by the same list, that will be better. Then this is a motor driver. So the functionality of each hardware, how they will be put together, how the design will happen, will come later on. Today's session is mainly to get you familiar with the kind of material required. And then after we share the list with you, you will be starting your procurement process also, so that we will be utilizing the next 1 week time. At least by the time you will be having this material, we will take up some activities on the design as well. So this is a motor driver, and then each will be able to drive 2 motors, so that we'll require 2 numbers over here. And motor driver is again a very important part of the robot, and this has to be a more rugged and robust driver, because many times I found that because of the large current drawn by the motors, maybe because of some failure in the robot, or maybe your mechanical robot wheel stuck somewhere and still it keep drawing the large current from the driver. This is the most critical component that get damaged during the robot performance. So that is how it is to be taken care of. And we always recommend that our teams also, that you always keep at least 1 or 2 spare along with you, so that you will not face a problem when you are going to perform some task with the robot. So this is an important component which is taking a digital signal from the controller, whichever controller you will be using, and it will be driving the motors, and the algorithm part you will be implementing on the controller side. So this will be sourcing all the current required by the motors to run at a large torque and at a speed that you are looking forward. Then we will be assembling the wheel part. So this is an element which is to be attached to the shaft, and then shaft will be connecting with the wheel. So this mounting is for the wheel. You will be coupling the motor with the wheel part. This is a bearing house, so that you will be supporting the wheel in the bearing, and then you will be connecting with the motor with the coupling. So all these building blocks are required once you create one single axis drive. So you will be having in a motor, you will be having in a mechanical shaft that you can see over here, then the bearing housing and the coupling, and then the wheel part you will be connecting. So all these, so this is the coupling part. Idea is that all load should not be coming onto the motor shaft. So that is how we need to support the wheel shaft properly, and couple with this flexible coupling to the motor. So we require these 4 couplings for the robot. Then these are the mechanism wheels that will be used. So we will be requiring 2 left-hand side and 2 right-hand side the wheels. So this is the right side wheels. And we require 2 left side wheels basically. So these are the 4 mechanism wheels required for making this robot. Then comes to the controller. So once you have a wheel, once you have a motor, and then you will be having a driver also. So at least these electromechanical hardware can be fitted to your base. And after that, your driver should be communicating with the the controller board. So the brain of your robot, as we were discussing earlier also, and this time also we'll see that all sensor interfacing, all motion control interfacing will be happening with the controller board, because here we will be writing all the programs to actuate the different mechanisms of the robot based on the sensing that you will be getting. Right. So in this case, we have options to select which platform to use actually. So I will be just showing you 3 different platforms over here, 3 different controllers. I should say that when I say platform, it's 3 different controllers over here, depending on the kind of task you will be performing. As you see that as we going along for various themes in the Robocon, you are mostly moving toward the vision processing as well. So we need to put more advanced sensors onto the robot. So many times people use LiDAR as a sensor, ultrasonic sensors will be there. And then optical sensors, basically for the line following you will be using. Then you will also be having a camera that can be used in the robots. So sensing world is now growing, and the controller capacity required to process that data is also required, which is a little higher. So we can give you an exposure and understanding of a different controllers and their capabilities. This Arduino is an easy to program controller. It's a microcontroller. Where you will get multiple IOs here. So digital input output terminals over here. Then you have an analog also. So this is a very capable Arduino over here. That is 2560 board. You have a lot of IOs available onto this. All these details certainly we'll discuss as we go along. But today just need to identify which hardware you will be preferring. And then it has a serial communication interfaces. And so this is one board that is possible that you can use on your platform. The another board that you can use here is the this ESP W Room 32 Wi-Fi. The good part is that this is again a good controller, the 32-bit controller. And you will be having a wireless capability into that. So whenever we are going for the manually operated robots actually. So manually operated robots, earlier people were connecting them with the wires, and they will be designing the pendant to control the robot part. But these days we will be using PS4 handheld controllers through which we can wirelessly communicating with this. So if you are requiring a wireless communication interface, so this is having a Wi-Fi as well as a Bluetooth onto that. So this controller we can connect with the Bluetooth, and PS4 can communicate to it, and you will be able to control the robot wirelessly in the field. So all manual controlled robot can be wirelessly controlled. So in that case, you need to have some Bluetooth communication available on your controller. So the previous board that I have shared with you was not having a Bluetooth. We need to add an additional shield onto that so that we can add a Bluetooth capability in the Arduino. But this controller comes inbuilt with that Bluetooth capability. So this is another possibility. It has a very good flash memory also, so you can have large programs running into this. So this is another option of the controller. The third processor, in fact, we will be discussing is the Raspberry Pi. So those who are familiar with the Raspberry Pi, so the current version is Raspberry Pi 4, which has again, which is coming in the 2 GB, 4 GB, 8 GB RAM capabilities. So this is the board which is running OS actually. The previous boards, we were not running operating systems. So certain applications, certain functionality can be done with the operating system only. So this is certainly a kind of a mini onboard computer for you. You can run Ubuntu into it. You can run Raspbian into this. So multiple operating system can be made to run. And once you run Ubuntu onto it, then you will be able to run an operating system like a ROS is there. So for controlling a robot, then the complete functionality can be done in the ROS on this. The earlier two were not supporting the ROS implementation because it requires an operating system to work on. So this is the high-end processor that you can use with your robot platform. And the good part with the ROS is that you can create multiple nodes and distributed processing. Sometimes we may be processing the vision part and then other LiDAR sensor, or maybe the additional sensor IOs that we will be processing. that will be more difficult to manage with the previously discussed boards. But this kind of a board with an operating system like Ubuntu running onto it and with the drivers available from the ROS, you will be able to process all that signals simultaneously. And we can also design the whole control system where you will be having multiple boards are also working. So that's a way of the distributed computing can also be implemented once we are going with the ROS. So all these options and provisions we will discuss so that we will be able to identify which all hardware we should be using for our robot. And another board that I am not discussing right now is again a costly board, that is an NVIDIA Jetson. That is another option that can be used for as an additional controller onto the robot. So these are the various platforms starting from a very basic price and capability to other side of a processor, CPUs and the GPU actually. So depending on what kind of sensor interfacing you will be doing and what kind of processing you will be looking forward, you can opt some of the combination of these boards. Then this is just a memory card for this Raspberry Pi only. The previous two controllers, Arduino and ESP32, may not be requiring this card because they have onboard memory and that has to be used for that. So they have a limited memory capabilities, but that is good for the embedded computing, and you will be writing directly the program onto their flash memory. You need not to put any additional expansion card like this. So this is only required for if you are using a Jetson or if you are using a Raspberry Pi. Then the most important part is the battery, because your robot is supposed to perform multiple tasks. So we need to assess the total power consumption required for your robot. And most important part is that it's supposed to run the whole task for the 3 minutes game. And we look forward that because you will also be doing some trials. So total AH required for this battery is very important. So this is an 12,000 milliAh battery, that is 12 AH battery. And we will be using this to power on all the motors and the controller part and the sensor certainly. So everything is requiring a power. So we have to estimate the total power consumption and the highest power being consumed by the motors only. That is how we need to see the large current being drawn by the motors. So we need to find out the size of the battery. So sizing of the battery is very important part. So this is the one we have selected for this robot that we will be creating. Then you need to charge this battery because this is a rechargeable battery. So you can have a battery charger that will be helping you in charging battery multiple times as you go along and try testing your platform. This is the DualShock 4 wireless controller for the PS4. This is the one we found that people have used extensively in the Robocon for communicating with the controller. So this is for manually maneuvering this robot platform. So when it comes for the manual control part, you will be using this hardware to wirelessly communicating with your controller, and then accordingly you will be moving your robot manually and performing various tasks. So manual control part earlier, before this controller, this wireless controller, people were using wired controller, but these wires can't be taken so long in the field actually, and they are sometimes entangling with the stuff on the game field also. So this is the handy part that you can use it to wirelessly moving your platform manually. So there are two modes. One is the manual control part and another is the autonomous part. So it depends on some of the tasks we would like to perform manually and some of the functionality we would like to implement autonomously. And this year's theme also, again, you will be free to choose the autonomous and the manual functionalities. This is the shield that you require if you are planning to use Arduino and this PS4 wireless controller, because Arduino as such don't come with the Bluetooth capabilities. So with this shield, you can add a USB functionality, and then you will be using this USB Bluetooth adapter, so that once you connect this, then Arduino will also be able to communicate with the PS4. So that is why we are looking forward that either if you are using a Raspberry Pi, it already comes with the Bluetooth capabilities. If you are using ESP32, it also have a Bluetooth capability. So you can directly pair this PS4 wireless controller with that. But if you are using an Arduino, then you need to put this shield and then this Bluetooth adapter. So then you will be able to communicate on Bluetooth. you require a good quality wires, and the, as I was mentioning, the current rating should be good enough, because this is another problem area. We rarely distinguish between the signal wires and the power wires actually. So this is important to understand where we are going to connect what cross-section wire. This wire 10 AWG silicon wire has been used, chosen basically, so that you will be powering up all your the power circuits, basically the motor driver to motor. So where exactly we will be using power wires as, and where we will be using the signal wires for the digital signal. So all that we need to decide, and we will be implementing this activity as well. So these are the 5 meter bundles that we have selected, because it may or may not be required completely, but you can have, sometimes it may be available in 1 meter choice also, that all you can decide and you can use it. Then these are the connectors for the power actually. So power connector should be very tightly coupled, so that there will not be any loose connections, so that there is a possibility that if it remains loose, then the sparking will happen, and by the time you are going on the field to perform the actual task, the connector burn out. So that is how these XT60 connectors are very good for making power connections. And we will preferring the connection with this silicon wires that we have, silicon insulated wire that I have shown, 10 AWG wire, to be soldered with these connectors and with a proper sleeve connections. All these steps will show you how it can be, so that the connection will be more rugged and tight, so that these minor pitfalls will not be there when you will be operating your robot. Then, as I was explaining, the naming of these wirings are very important. The naming of the connections that need to be done, so that you can identify the cables very easily, that which cable is used for which connection. So looking at the, because at the end, you will find there are many wires running around onto the robot platform, but how you will be identifying them? So we will be using these PVC ferrules basically, which are numbered 0 to 9, so that you can put these ferrules on the wire, and then you can easily identify them. So this is the pack available with the different sizes, so that we can earn the numbers also. Then comes the mechanical fabrication part. So we will be using 20 by 20 40 slotted aluminum extrusion, and same profile is available from the link that I will share with you. So we require this 7 numbers, and each is ½ meter long. So you have to buy this section. So then we will be cutting them, or we will, if they are in the standard ½ meter size, we will be just joining them together. So that is how this aluminum extrusion we will be using to create the basic robot structure. And this is for the base. So 20 by 20 we will be using for the base, but we may not be using such a heavy cross section for the other linkages. So that we'll discuss later when we create those things. But the base platform has to be rugged, and the complete weight, maybe whatever 20-25 kg is the total weight of the robot coming up, all has to be taken on this aluminum extrusion profiles. Then these are the elements to join these aluminum profiles. So this corner brackets for 2020 aluminum profile need to be purchased, so that we can join them at a 90°. Then these are some of the T-nuts that are sliding inside the aluminum extrusions, and then you will be tightening those bolts. So all these activities we will explain when we go during fabrication, but you need to have these items available with you. Then these are the bolts that you will be using, the Allen bolts with the M4 cross head. So if you see that there's a M4 nuts are there, so M4 bolts are also required. So this will be required. Then there are different types of nuts and bolts that are required. So we just give you some recommendation to buy this. And these are the additional fixation materials are required, just a nylock nut and the washers, countersink heads, and the socket head cap. So these are the Allen bolts that are required for fabrication. Then comes the wiring. So these are the wires we mostly use for the digital connections. So they are coming in the multiple colors, so that you can easily identify the color of the wire. So we look forward for the different interfacing, but certainly these are only used for the testing. Final connection will not be doing with this male-female connectors. It has to be soldered or to be used with the proper connector so that it will not get loose while the operations is going on. Because many times you need to transport your robot also for at the different locations. Those who are coming for national participation, they will be bringing to Delhi. If they are going for the international event, they have to take it to some other place. But this time it is in India only. So, but still you have to transport your robot from one place to another. So it has to be rugged enough so that your electrical connection will not get disturbed as you keep moving this robot. So, depending on the kind of connection, we discuss all these aspects also, which type of connector to be used when we will be making these connections. Then these are the terminals that we need to prepare so these are the lugs that we will be fixing to join the two wires actually. So many times you need to disconnect the wires. For example, you need to replace a certain element or certain component. You will be plugging and unplugging it very fast actually, but at the same time the connection should not be loose also. So these are some of the connectors that we will be using for connecting and disconnecting some of the components on the robot. Then these are the heat shrink sleeves, mainly for the insulation, and then wrapping around the electrical open surface, basically the metal surface. We need to put that into the wire and the connector so that it will be covering it properly, so that it will be acting as an insulator. It's a heat shrink that once you put this loose sleeve onto the wire, and then you have to just warm with a hair dryer or some hot air gun. Then this sleeve shrink actually. As you heat this sleeve shrink, and it will grip the wire properly and put it. So this is a better option than putting an insulation tape. Many times we find that people are just adding the insulation tape on the joints that they are creating on the robot. So just to avoid that, wherever we will be having in the connections and joints, we will be placing this heat shrink sleeve, and it is coming with the different sizes, so that depending on the different wires, you will be placing these sleeves and then joining them. Then we also require these ferrules for connecting them to the screw terminal. So wherever you have a screw terminals, as I was explaining, all industrial automation connections being done with the help of these thimbles or the wire ferrules, where you will place the wire inside it, then you will be crimping. You can crimp it with the plier also, and then you put this into the screw terminal and then tight the screw. So most of the connections we need to see the electrical connections where the soldering need to be done and where the screw connections to be done, because sometimes you need to replace the component and sometimes you need to permanently solder the wire. So all these things we learn as we go along while we are creating the electrical connections. So I think that is all the component that I have just listed over here. And so this is the complete list of component that we need to procure. And once we have this material available, so that when we will be sharing with you what step need to be done, which component to be used, you will be able to correlate with the same material that you will be having when you will be developing this robot. So after this, I just want to take you through some of the tools, though I have explained earlier also in the previous session. So basic tools are required. Most of the tools are available in house also. But if you don't have, then you can at least get some of the basic tools. For example, the drill may or may not be available at the home, but rest of the screwdriver, hammer, plier, these are already available. So drill and drill bit you need to purchase. So this drill and drill bit may be coming around 1,000 rupees or so. So that is what the additional thing. All cutting operations, if you have an access to the power saw, you can use it, because we will be using power saw in our workshop. We can use it. Otherwise, the hacksaw can also be used. So hacksaw you have already operated in your engineering first year, so you know that how to cut the things. So mainly, if you are getting all cut sections of equal size, what we require, then it will be nice. Otherwise, we will be cutting it and then you will be joining them. So that is how the basic tools that are required. This is an important part when we will be cutting the aluminum at an angle actually. So that is what is required, and sometimes you have to hold it. So this meter saw is something which will be helping you to cut the aluminum section at a certain angle. So if it is 90 degrees, certainly you can cut in a simple voice also. But this meter saw is mainly useful when we have to cut at a different angle. So if it is certainly, if you are working at home, you may not have an access to this. So in that case, you will be using the saw itself. See, all of you have basically invested a lot in your engineering education and still be investing into that. This activity, what we are trying to do, is certainly more exciting, and even spending a little more onto this will not basically go waste. You learn a lot of skills basically, and believe me that the more and more practical things you will be doing, you will be enjoying engineering to a great extent. And that is what I also felt actually, because I know that whenever we were in the school days, we always love to do science projects, and we like to build something. And once we learn something from the textbooks, we always like to experiment with it. So robotics is such a field that once you learn something, you would like to do experiment immediately actually. So that's a very important part. You should have a passion that to see that how an autonomous mobile robot move, how it detects the obstacle. And because these days you need to put a lot of intelligence onto the robot also. So how that intelligent processing will happen, what input you will be getting, and what action your robot is going to take, all basically making them functional is very exciting learning actually. So it's bringing out the learning of the mechanical design part, the electrical part. So I'm not distinguishing between those who are coming from a different engineering stream. When we all together in the robotics, we all are supposed to get a knowledge of all the basic building blocks, whether it's a mechanical design part, or whether it's an electrical connection part, whether it's in a motor driver actually. So even mechanical engineers should understand the motor driver. Take it as just a building block actually. You might have done some experiment with the Lego blocks. So in that case, you will be just connecting some elements together and understanding basic minimum things. May not be going deeper into the silicon level. No, it's not required. So not even at the device level. So once we have a basic understanding of the integrated circuit and what all interfaces it requires, I think that understanding is good enough to build the robots. So in this exercise, we will be going through all the steps, and each one of you who will be coming from a different background supposed to learn all these small steps. And I'm sure that we will be leaving all those stream barriers, engineering stream barriers behind once we found ourselves doing robotics. And then you will be enjoying the stream mode. Even you may not be doing all these activities, but if you have that overall understanding of the different engineering blocks actually, then it will be easy to guide a team also. So if you have people, normally whenever we create a Robocon team, we always identify them. This is a mechanical team, this is an electronics team, this is in a programming or computing team, or the software development team. It's good that they will be focusing more on that aspect of the activity, but they should also be aware of other activities actually. So that's the important part. So this basic learning is very important. And then you can specialize, and depending on your interest, you can just focus on one part of the activity, because then you will be able to master that. So that is what my suggestion is, that from whatever background you are, we have to do all the activities together when we build this robot. So these are the power tools. I'm not sure while being at home, you may have access to that, but these are always good to have. Voice is always good. Even if you're at home, you can have a voice, because while cutting, while fixing, doing some operations, you can fix it somewhere and then you can cut it, because otherwise holding an aluminum profile and cutting it may be difficult, little bit difficult actually. So voice can be managed also. So certainly as an engineer, you can have some corner at your home where you can be doing this activity. So just communicate with your parents that I'm going to do this activity for next few months actually. So I will be looking forward for a small workshop kind of a place in my home so that I can do that. So I always love to have that kind of small space where you can work physically and then you can create this kind of a platform. So that is what my suggestion to all of you. These are the tools that we will use later on. So we will be spending time on understanding the digital manufacturing later on, but how to generate them, because we need not to own these equipments. We will be just utilizing the services available over the different websites. Only thing we need to understand what data to be generated so that we can transfer that data to these manufacturers so they can give me the final finished component actually. So all these laser, CNC router, additive manufacturing, and all these services are available. So need not to invest on this costly equipment. You can only pay for whatever component you are looking forward. So for this boot camp, at least the basic materials and tools, whatever we discuss, that is what we are expecting. That drilling machine for the metal, and this is very important. The drill bits for the metals are completely different for the drill bits for the wood or the other soft materials, actually, even for the acrylic. So especially we will get drill bits for the metal, because we will be going to make holes in the aluminum wherever it is required. A screwdriver set will be available, spanner set can be managed, pliers. So fabrication on aluminum, I think this may or may not be available. As I say, the all cutting can be done with the hacksaw also, but it takes a lot of effort and time actually. If you can manage to have this power tool, that is always good. Otherwise, the electronic tools are also required. So soldering is required. So if you have not done soldering earlier, let's start doing that part, because you need to do soldering in this case, certain components. What all accessories required for performing the soldering. So that is again an art. I will show you, miss, how you can do a good soldering, and rest is the aluminum sheet or the acrylic sheets. So this is all from my side, what all resources you will be looking forward for this activity. And this is the preparation for this exercise that we are going to do till mid of the February. This is all from my side. Now I'm just leaving this platform for your discussions, and if you have any query, please let me know. I hope you get a sense of the kind of material that you are requiring for making this robot. That is what the idea of having this session, so that we'll understand that what I'm supposed to gather to start this activity. Is this clear? Actually, you can just respond to that itself. At least you'll get some idea about what all is required for making the robot. So I am looking forward for the response. The silence doesn't indicate anything.
Yes, sir. We got pretty much everything like.
Okay, good, good. Thank you. Thank you. That's nice. So what we will be using, certainly these kind of live sessions we will conduct more frequently as we go along. Apart from 11 to 13, we'll have a few more sessions like this whenever we will be doing this activity, mainly for the preparation actually. So whatever we will be spending time is the preparation activities. I will be preparing the calendar of activities that we need to do before we reach out to the final day, so that we'll have all the resources, what software tools to be used, what software to be learned actually, that is important part. And certainly some kind of a basic design preparation and all that we can start actually, so that we will be using. So you have final exam on the same day of the on the same day of the exam is the solution of boot camp. No, it will be difficult to postpone this time, and certainly we may look forward to associate again. Mr. Shashidhar, I am really sorry, because we are fixing these dates. We also have a constraint otherwise due to other activities.
Excuse me, sir.
Yes, yes.
Sir, we'll be using some servo motors in the build.
No, servo motor we will not be using. What we will be doing, we will be implementing the closed loop control with this DC motor with the encoder actually. So servo motor certainly will be very costly. We may not be requiring right now. For this motion control, we will be just building all those closed loop through the programming, because we have encoder and we have a motor, a DC motor to control. So we will be trying to implement around that only. Okay. So the motor that we have selected is a DC motor, and we have not chosen the servo or the stepper and other. They are not required for this functionality, because base platform is supposed to move at a certain speed. That is one thing, and it has to be economical also. That is what the servo motor and drive is certainly a very costly thing to integrate here. But this learning, whatever you go through, you will at least get to know about the basic component selection is also very important part. Tomorrow, if you are going to design any industrial autonomous mobile robot, there we normally use servo motors and brushless DC motors with the motor drivers. So drivers plays a very important role. So we will be sharing all that information that is important to learn for this. So that the right selection of the motor driver, what we should be looking as a feature into the motor driver, what interfacing it will be having with the controller board, and how the program will be controlling the motion part. All these things we will learn apart from the basic mechanical design part. Which files, Ranganathan, you are asking? Sri Ranganathan, you are there?
So which is requirement files?
Yeah, certainly. So what I have just mentioned, this FSM skills platform. So because you all are now get connected with me on the WhatsApp group. So what I will be doing the moment I create an account for you on this FSM skills website, I will share on the WhatsApp group. And then once you have an access to that FSM skills, whatever I will be posting over there, I will be sharing with you. So you will be getting all the information, all the files, all the resources on the same page. So we'll be certainly sharing with you. Dhananjay asked this question that can we use drone radio controller to control our controllers because they have high range and accuracy? No. So when you say high range means to what range? Because most of the manual control in the Robocon, we look forward for the 10 to 15 meters only. We don't see any kind of a control, and that too is the extreme actually, because our game field is not bigger than that. Drone certainly has to fly at a much different height actually. So we need long range wireless communication, but there is no constraint as such. Certainly, if you already have something which can be used for this, you can plan to interface for that. But we will be giving tutorial specific to the hardware that we have mentioned. For other hardwares, you need to explore yourself actually. So if you have some other controller, you can use it. Accuracy, I don't understand when you say accuracy means what? The positioning accuracy of the robot, you mean that?
Yes, sir, like robot not going out of control.
So certainly, see, the Bluetooth we are talking about and the pairing of this PS4 with your hardware, it will easily work within the field area of the Robocon. And that is good enough. And regarding the positioning accuracy, it doesn't comes from the hardware alone. It certainly comes with the kind of an algorithm that you will implement into the controller. So then only you will be able to position it properly in the field. Right. So we learn as we go along. We'll at least give you some examples and understanding on that.
Excuse me, sir.
Yes, yes.
Sir, what is the completion of stage 1? That is 2,000 rupees payment process.
Can you repeat question? In between, I just lost your voice.
What is the last date for registration of stage 1?
24th of February. So if you see on the website, ddrobocon.in, it is already mentioned this, the last stage for submission of your entry for the stage 1 is 24th February.
Sir, I have a doubt. Sir,
yes,
actually, I have registered as an individual participant, but in my college, there is a group participation of 20 or 30 people.
Yes.
So as a group participant, can you consider my participation as a group or individual?
Individual only, because this boot camp is for the individual participation only.
No, sir, for this submission of the entry in stage 1.
Stage 1, that is from the institute actually. That is a representation from the institute. That is not from individual actually. So as a group captain, you will be submitting the entries, but this entry is on behalf of the whole team actually.
Okay, sir. Thank you. So that means the total registration is from IIT Ropar for the stage 1.
Yes, yes. There is a one team from IIT Ropar for the stage 1. Yeah.
Okay. Thank you, sir.
Okay, thank you.
Sir, can we use Omni wheels rather than Magna?
Yeah, so that is what I said. There are 3 type of possibilities for the wheelbase. So we will discuss the pros and cons of these also when we discuss the design aspect. So you have an option for the differential drive where you will be using a normal wheels and then you will be controlling or maneuvering the robot. Then you have an option of omni wheels and then you have an option of mechanism wheels. So there are multiple attempts that people have made on these different type of configurations and what are the pros and cons. So we'll have a session and then we'll understand that. So if any one of you are willing to try out with a different mechanism also, we are open for that also. So if you are looking forward, so what we recommend is the 4-wheel mechanism drive. But if you look forward for the differential drive, or if you are looking forward for the omni wheel drive, that can also be tried out. So we can even discuss those aspects as well. You can use, actually there is no restriction as such on any of the 3 options. How well you will be able to maneuver and control the whole robot platform at what speed. Certainly the most important part is the straight motion that you need to perform and the turns it has to perform actually. So these are the 2 critical functionality that you have to meet. And different wheels will have a different pros and cons. Some may go straight very fast actually, but then turning will take some time. Turning radius is another option, another parameter that we need to consider. And moving in any direction will be a problem. So sometimes you need to turn and then move. Sometimes you can easily move in any direction. So these are the different options we need to evaluate while we will be selecting the base and the drives basically. Wheel types. So there will be a lot of learning for all of us. What I will do, I will be adding these e-learning resources also onto the e-learning website, so that you can at least get some glimpse of the pros and cons. And because we will be looking forward this whole group and will distribute that into subgroups basically, so that you will be discussing the possible options, sharing that learning with the other group and team members also. So there are some, if you decided to do experiment with a different kind of a drive, please let us know in advance, so that we'll also be assisting you in implementing that. But it's fine actually, if you are looking forward for some other platform and some other drive system, that is also okay. While using encoder, DC motor perform as a stepper motor. No, it is not performing as a stepper motor. So this difference is different. Encoder is just to capture the rotation part. When we talk about the stepper, we are controlling step by step actually. So here controlling is not step by step. Controlling is just in a current into the DC motor, which will be controlling the torque, and it will be generating the speed based on the torque speed curve. But we will be getting in a continuous feedback actually, that we will be utilizing to give a further command or for the current to the motor. So that is the process of a closed loop control. But the stepper and this DC motor with encoder are 2 different systems altogether.
Excuse me, sir.
Yes, yes.
Sir, for image processing, should we use Raspberry Pi?
Yes, certainly, because other 2 platforms can't do image processing. If you are intent to use any kind of a camera, then the smallest platform that you have to use is the Raspberry Pi.
So how much RAM would be sufficient for that, sir?
How much?
RAM, sir? Like 2 GB, 4 GB?
Depending on the camera also, because if you are using a Raspberry Pi camera, then 2 GB will be sufficient. And if you are going to use any high resolution camera with that, then you may require a little higher RAM. Because if we say that, if I tell you that I have to use an Intel RealSense, then processing platform should be different. If I am just satisfying myself with the Raspberry Pi camera, then 2 GB RAM is good enough.
Yeah, okay, sir.
Okay. Certainly hardware related and the technical questions we will be taking during the sessions also. My suggestion is that you can utilize the WhatsApp group for any other query comes to your mind during even beyond this interaction hours also. We would like to respond to that. And before we actually narrow down to what platform you will be making, I'm assuming whatever I have shared, all of you will be doing that. But if you look forward for any change, you please intimate us in advance. What design changes we can make after submission of the abstract? Abstract means the stage 1 entry. Minor modifications we look forward should be permitted, but the more or less the overall design should remain same. So if you are reporting the base platform size and other things, So intent is that you should have completed the design phase at least by the time you finish stage 1. The different stages and different timelines has also been kept to keep you working throughout. It doesn't mean that the last day you are going to design and fabricate everything in the last 1 week or so. That is not encouraged. So you will be starting at the design phase. So we are expecting at least you will be able to complete the design part till the stage 1. Minor changes, minor modifications can be done, but not the major changes that so it should not be completely different what you fabricated in the stage 2 than what you have submitted as stage 1. There's also a weightage of the stage 1 evaluation. That is also important part as the final selection will happen for the final game. So you have to think from the beginning itself. That is the idea here.
Sir, actually, I was unable to find the registration link for this.
Registration link has not been provided till now. We are still hoping that people are working. They are not willing to submit the design. So registration link will be available during the last 1 week of the submission actually. Only the guidelines are available right now. So if you go to the website, only the guidelines, what you are supposed to prepare, that is made available. The registration and the upload link will be made available a week before the last date. So maybe roughly around the 17th of the February or somewhere. Okay.
Yes, sir.
Fine. So thanks. Let's work and enjoy this activity together, and hopefully we'll be all able to create some kind of a robotic functionality by end of this boot camp. And please be connected on the WhatsApp. And once I created the account on the FSM skills, we will be exchanging information through that as well. So thank you very much for this first session on the bootcamp. And I'm still looking forward that if any one of you feel that you need to work in a group and you want to involve any of your friend, let us know. This is the early stage. We can think about that because we always suggest that if you are working 2 people in a group where you have a good understanding, that is always better to create this platform. Otherwise, what we will be doing, we will be creating in a small groups out of this registered participants, and then that will be a kind of a team for you to work on.
Sir,
Yes, yes, Venkat.
Sir, now if they think that their group should come into